Welcome to Programming with Professor Califf. Today I'd like to talk about strings in Java. In our primitive variable types in Java, we only have one type that has to do with text data, the char or char type. While it's useful in some circumstances, there's a limit to how much we can do with a single character. Most of the time we need longer units of text. The designers of Java are aware of that, and so one of the classes that the Java language provides for us is the string class. String is a somewhat unusual class as well as a very important one, so I'm going to spend a little time introducing you to the class and its capabilities. Let's start by briefly reviewing our character data type. So the char contains exactly one character. It's a primitive variable. The character values or literals are set off with single quotation marks. So here we have a few examples. The letter M, the percent sign, capital A, the digit 9. Notice that this is different from the number 9. On the string side, we have 0 or more characters. The string is an object, so a string variable is an object reference variable like we talked about in our last video. Our string values are set off with double quotation marks rather than single ones. And here are a few examples of string values. We have the empty string, hello world, United States of America. We want to be very, very clear that the character A in single quotes is not the same as the string containing only the letter A, although the string does contain the character A along with some other things in that object. Before we move on, we need a quick vocabulary lesson because I'm going to be talking about string literals, and you need to know what I mean by that word literal. So a literal is a value of the type that we're talking about. So integer literals might be things like 3, 5, 10, 3,285. Floating point literals would include things like 3.14 or 2,975.32. Boolean literals, there are two of them. They are true and false. And character literals are things like A, the ampersand character, the character 3. And then a string literal would be something like the string computer science or the examples I had on the previous slide. We want to be able to work with strings as variables. We've actually been working with string literals from the very beginning. First, we need to be able to declare our variables. Our type is string with a capital S, so a declaration will look like this. We know that our variables aren't of much use until we give them values. One way to do that is to call a constructor, just like we did with our savings account variables, and that works just fine. So this would give us my string containing the value roses are red. But Java has treated string objects as special because they're so common and have values that are easy for us to write. So we have a second option, which is the one we'll actually typically use. We can just say my string is assigned roses are red, or any other string literal, and Java will essentially call the constructor for us. It'll do the work of setting up our string object for us with that value. Another thing that is special about string objects is that they're immutable. You can't change them. Now, we can make the variable point at a new object. Remember, it's a reference variable. So we have this myString variable that is pointing at the actual object. When we do the assignment of myString gets violets or blue. The original object hasn't changed at all. We've just changed the value of the object reference variable, myString, so that it's now pointing at the new value, the new object. We haven't actually changed and cannot change the string object itself. Before we take a look at what we can do with strings, we do want to understand that strings are made up of characters. We can identify the individual characters by index. Notice that the indices begin at 0. So here's an example with roses are red. It has 13 characters. The first one, the R is 0, then the O at 1, and so on. So the two spaces are at indices 5 and 9. Note that those spaces are also valid characters that have indices. Now we know that objects have methods that we can call, so we can do stuff. So I want to take a quick look at some of the capabilities of a few of the string class methods. So the first ones I want to look at are char@. So this is a method that returns a char, and it has a parameter. Remember, we had parameters like with the withdraw method and the deposit method. So in this case, our parameter is an integer that represents the index. So what we get is the character at that index in the string. So first char with my string, where my string is roses are red, would return a capital R. So first char's value would now be that capital R. We also have a length method. This one's very useful if you want to know how long your string is. So it just returns an int that's the length of the string. Doesn't have any parameters because it's just working on the string itself. So in the case of our roses are red, that was 13 long. So sterling will be 13. And we have a couple that are kind of nice if we're needing to deal with cases, which we sometimes do need to get things all in uppercase or all in lowercase. So to uppercase returns a string. Now this is a copy of the string. Remember, we can't modify the original string. So the things that are doing modifications to the values of the string are returning a new string with those new values. So this is a copy of the string that has all of the letters uppercase. So in this particular case, that would be roses are red with all caps. Now the blanks wouldn't change because they're not letters. If we had digits in there, those would not change either, or punctuation or whatever. Just any letters that are in there will be uppercase. And to lowercase does the same thing with lowercase letters. So this would return exactly the same thing, except that that capital R would be a lowercase r. Index of is nice if we want to figure out where something is in a string. So we have a few versions of index of. This first one takes a string. So this is one or more characters we want to match. Theoretically, you could do it with the empty string, but don't, because that's a bad idea. And it's going to return the index of the beginning of the first occurrence of search string in the string. And if it's not there at all, it'll return -1 because that's not a valid index. So that's what we use to say, hey, didn't get it. So with our roses are red, our index of R was at 6, of the A in R was 6. So search start would be 6. Then we have one that will tell us a starting place. So this one starts at the beginning of the string. We can also feed it something that actually we specify start from this point. So if we had a string abracadabra and we said Sturlock gets string 2 dot index of and passed it AB, but gave it this index 2, then it would start looking. This A is at 0, this B is at 1, this R is at 2. So it starts looking there. So it will turn this index, which would be 0, 1, 2, 3, 4, 5, 6, 7. So Sturlock would be 7. We also have a version of the index of methods that takes chars instead of whole strings. So that's looking for a specific character, but otherwise they're working exactly the same way. So in this case with search start, we'd be looking for the index of the very first space that it found because it's starting at the beginning, which would be 5. But in this case, we would find the index of the second space, which I believe was 9. Then we also have some things where we might want to extract a piece of a string. And so that's called substring. And it has a couple of versions that we're going to look at, has several other versions as well. So one of them, we give it a start index and then an end index. And it's going to return a copy of the portion of the string beginning at the start index, but ending with end index -1. So it's not going to include the character at end index, just up to that point. So if we wanted to extract out the R and get just that substring from our original string, we could say that string second word is my string dot substring 6, 9, because 6 was the index of the first character, that A, and 9 is the index of the second space, so the next character after the E. So that would extract ARE. Then we also have a version that only takes a start index, and that will give us the rest of the string from that point. So if we wanted to get the third word, the red, we could say string third word is my string dot substring 10, because 10 is the index of the R in red, and then we would just go to the end of the string, which is what we want to do in this case. I hope this gives you some sense of what we can do with the string class. This is by no means complete. If you're interested in seeing more of the capabilities of the class, go to your favorite search engine and search for Java String API, or you can I'm going to search for Java String API 14, because I know that the version of Java I'm using is 14. But the string API has not changed a whole lot. So let's do that search and pull this up. So you're going to find something at docs.oracle.com, because Oracle owns Java. And then this has to do with the API. We talked a little bit about an API last when we were looking at the account class, not in the last video, but the one before that. So here we have, again, documentation similar to what I showed you with savings account, so that it's much bigger because the string class is a much more capable class than the savings account class. But we can scroll down, and let me just zoom this in a bit so it's easier to see. But we can scroll down, we can see lots of different constructors, so lots of different ways to build a string. Then we begin to see methods. So we've got the char@ method, which we see return the char value at the specified index. And if we want to see more details about the method, we can click on the name and see more information about it. And then there are various others. So concatenation is going to allow us to put two strings together. We've got a compare to that compares a couple of strings. Are the contents the same? There's an equals ignore case, which lets us compare two strings, see if they're the same, but leave out case. We've also got an equals that doesn't leave out case. We've got the index of with, as I said, we've also got last index of, and replace. So we can actually come in and say, okay, give me this string, but replace these characters. We've got ways to split them up, put them together, strip off spaces, check to see if something has white space only, check to see if it's empty, the empty string. So lots of different capabilities. I encourage you to check it out. So thanks for watching. In the next video, we'll talk about the scanner class in Java, which is one way for us to get input from a user into our programs.